Introduction to Statistics, Chapter 5, Probability, Section 5.5, Counting Techniques. The multiplication rule for counting. If a task consists of a sequence of choices in which there are P selections for the first choice, Q selections for the second choice, R selections for the third choice, and so on, then the task of making these selections can be done in P times Q times R times blah blah until the end, different ways. Example, a man has 6 shirts and 4 ties. Assuming they all match, how many different shirt and tie combinations can he wear? Well, in this case, the first event has 6, the second event has 4. So this is going to be 6 times 4, or 24 different combinations. Factor notation. The factorial symbol, the exclamation point, denotes the product of decreasing positive natural numbers. 3 factorial is equal to 3 times 2 times 1, which would equal 6. 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. If you multiply it all out, you get 720. So n factorial would be n times n minus 1 times n minus 2 all the way down to 1. Now some special factorials. 1 factorial is equal to 1. 0 factorial is equal to 1. They both equal 1. They're 2 different factorials. Now, why does 0 factorial equal 1? Because if it didn't, a lot of our formulas would not work. So that's why 0 factorial is 1. Now, evaluate 6 factorial. Okay, we can do this 3 ways. We can do it by hand, we can do it with a calculator, we can do it with StatCrunch. Okay, if you're going to do it by hand, you're going to use the formula, 6 times 5 times 4 times 3 times 2 times 1, and just multiply it out, and you would get 720. If you're going to use the TI-30, in this case, you're going to enter 6, then you're going to press the PRB key, which is the second row down, second key in. Use right arrow to move to the exclamation point, press the equals, and then press equals again, and you will get the answer 720. Now, using StatCrunch. First, you're going to open StatCrunch. Click on an empty cell. Click Data on top menu. Highlight Compute, choose Expression. Enter Fact, parentheses 6, in expression space, click Compute, and you will get 720 show up. So there's 3 different ways to evaluate 6 factorial. Okay, evaluate each of the following. Pause the video for a second, try to evaluate these 3, then come back and check your answers. 9 factorial would be 362,880. 7 factorial would be 5,040. 11 factorial would be 39,916,800. Now, the factorial rule. A collection of n different items may be arranged in order n factorial different ways. Example, how many ways can 5 books be arranged on a shelf? Well, first, let's put 5 lines for the 5 books. Okay, how many ways to pick the first book? There'd be 5 ways to pick the first. 4 for the second, 3 for the third, 2 for the next to the last, and 1 for the last book. So this is just 5 factorial, or 120. How many different ways can 8 people stand in line to purchase concert tickets? Well, again, we're going to have 8 spaces in line. So now we ask ourselves, how many ways to pick the first person in line? Well, that would be 8. So then there's only 7 for the second place in line, 6 for the third, 5, all the way down to there's only 1 person left for the last position. So this would be 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which is 8 factorial, or 40,320. A lot of different ways 8 people can stand in line. Okay, now we want to talk about permutations. A permutation is an ordered arrangement in which R objects are chosen from n distinct different objects so that R is less than or equal to n, and repetition is not allowed. The symbol NP PR represents the number of permutations of R objects selected from N objects. So sometimes it's helpful to think a different order is a different permutation. In other words, 1, 2, 3 is different than 3, 2, 1 is different than 2, 1, 3. So a different order is a different permutation. Remember, order is important when it talk about permutations. Now, number of permutations of N distinct objects taken R at a time. Well, the number of arrangements of R objects chosen from N objects in which, number 1, the N objects are distinct, no repetition. Repetition of objects is not allowed. And 3, order is important. What I talked about earlier, 3, 2, 1, 1, 2, 3, they're different. Okay, and the formula is NPR is equal to N factorial divided by N minus R factorial. Now, so we can evaluate this 3 different ways again. So if I wanted to evaluate 6 permeated 4, I could do it by hand, I could use the TI-30 calculator, I could use StatCrunch. Now, if I did it by hand, I'd throw it into the formula. So that's going to be 6 factorial over 6 minus 4 factorial, which becomes 6 factorial over 2 factorial. Then if I expand it, 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1. Now I can cancel out the 2's, I can cancel out the 1's. So I just take 6 times 5 times 4 times 3, and I get 360. Now if I was using the TI-30, I would enter 6, press the PRB key, which remember is the second row down, second key in. This time I would choose the NPR, press equals, enter 4 this time, press equals. Okay, and that would give you your answer of 360. Now using StatCrunch. Again, you're going to open StatCrunch, click on an empty cell, click Data on top menu, highlight Compute, choose expression, enter perm, parentheses 6, comma 4. Perm stands for permutation. In the expression space, click Compute. And you would get 360. Now, most calculators will have a permutation option on them someplace. So evaluate each of the following for practice. So if you pause the video for a second, work these out by hand, calculator, or StatCrunch, and then come back and check your answers. Okay, 5 permeated 3 should have been 60. 10 permeated 7 would have been 604,800. 12 permeated 10. This would have been 239,500,800. Now, application problems involving permutations. We're going to talk about permutations combinations. You're going to have to know by reading the problem whether it's a permutation or a combination. Now remember, permutation is about different orders. So, number 1, how many different slates of 4 officers, president, vice president, secretary, treasurer, can be selected from a club containing 25 members? If you look, if Joe was president, Sam was vice president, Sue was secretary, Sally was treasurer, would be one set of officers. But what if I turned it around? What if I said Sue was president, Sally was vice president, Joe was secretary, Jim was treasurer? Well, I used different names. I should have used the same names, but I forgot. But if you change the order, it is a different set of officers. So this is a permutation. So remember, a different slate of officers would be a different order. So we're going to do 25 permeated 4. And that turns out to be 303,600. So there'd be 303,600 different slates of officers possible from this club of 25 members. That's a lot of slates of officers. Question 2. A manager must select 5 delivery locations from 9 that are available. Find the number of different possible routes. In other words, he's going to go from one location to the next, to the next, to the next. But he's going to use 5 out of the 9. So how many routes are possible? Well, this would be 9 permeated 5. And if you calculate this, you would get 15,120 different routes. Now, we're going to talk about combinations. A combination is a collection without regard to order, in which R objects are chosen from n distinct objects, with R less than or equal to n, and without repetition. The symbol NCR represents the number of combinations of n distinct objects taken R at a time. Sometimes it's helpful to think a different grouping is a different combination. Now, in this case, ABC would be the same group as CBA. In other words, the order, you still have the same group. Okay? So this is the difference between combination and permutation. A different order gives you a different permutation. A different order does not give you a different combination. Number of combinations of n distinct objects taken R at a time. The number of different arrangements of R objects chosen from n objects in which the n objects are distinct. Repetition of objects is not allowed. There's no objects repeated. And order is not important this time. So the formula is NCR equals n factorial over R factorial times n minus R factorial. If you look at this, this is very similar to the permutation, except for we've added an R factorial in the denominator. Now think about it for a second. If I make the denominator larger, will my final answer be smaller or larger? So will a combination be smaller or larger than a permutation? Well, if the denominator is larger, that's going to make your number of combinations smaller than your number of permutations. So let's evaluate. Again, you can do it by hand using the formula. You can use the TI-30 or you can use StatCrunch. So it's going to be 6 factorial over 4 factorial times 6 minus 4 factorial, which is 6 factorial over 4 factorial times 2 factorial. Now, this time when I expand it, I'm going to leave the largest factorial in the denominator. So 4 factorial is largest. So 2 factorial is 2 times 1 times 4 factorial. Now when I do the numerator, I'm going to bring it down to 4 factorial, because isn't that 4 times 3 times 2 times 1? So it's 6 times 5 times 4 factorial. Now, I can cancel out the 4 factorials, simplify the 2 and 6 to get 3. 3 times 5 is 15. Working this one by hand was not very difficult. No need for a calculator. Now, if you're going to use the TI-30, you're going to enter 6, press the PRB key. Remember, second row down, second one in. Choose NCR, press equals, enter the 4, press equals, and then you will get your answer of 15. StatCrunch, we're going to go about the same process. You're going to open StatCrunch, click on an empty cell, click Data on top menu, highlight Compute, choose Expression, enter COM, parenthesis, 6, 4, parenthesis. The COMB stands for combination in the expression space. Then click Compute, and 15 will appear. So you can use StatCrunch to do permutations, combinations, and factorials. You can use the calculator, or you can work them by hand. Okay, and most other calculators have the combination option on it someplace, but you'll have to figure out how to use that yourself if you're using a different calculator than TI-30. Okay, so here's a couple to practice on. Evaluate each of the following. Okay, so pause the video, calculate these, and come back and check your answers. Okay, 5 combination 3 is equal to 10. 10 combination 7 is equal to 120. 12 combination 10 is equal to 66. You notice these numbers are a lot smaller than your permutation numbers. Now, application problems involving combinations. How many different simple random samples of size 4 can be obtained from a population whose size is 25? Now, if we think about this, you're talking random samples of size 4. Is order going to matter in that sample size? In other words, if I had 4 people, does it matter which person I chose first? No. So this is similar to grouping. Okay, so therefore this would be a combination. So we're going to want 25 combination 4, and this would turn out to be 12,650. Number 2, in your literature class, You are given a list of 10 books. You are to select 4 to read during the semester. How many different combinations of 4 books are available from the list of 10? Okay, first, order in which the books are selected is not relevant, implies combination. In other words, it doesn't matter what order you pick the books, you just have to have 4 books. So this is a combination. So this would be 10 combination 4, which would be 210 different combinations of the 4 books. Now, this is a more complicated problem, okay? So suppose that there are 55 Democrats, 45 Republicans in the U.S. Senate. A committee of 7 senators is to be formed by selecting members of the Senate randomly. So, what is the probability that the committee is composed of all Democrats? Okay, remember, we're picking them randomly. So the first thing we have to do is all Democrats implies no Republicans. Keep that in mind. Now, so the number of committees with all Democrats is, so we have 55 Democrats and I want 7 of them. So that's 55 combination 7. Now, there are 45 Republicans, but I want none of those. So that's 45 combination 0, and we multiply these combinations to get the number of committees with all Democrats. Total number of different committees, well, if you add the 55 Democrats, 45 Republicans, you get 100. So this is 100. The committee has 7 people on it, so it's 100 combination 7 for the total number of different committees possible. Now, so the probability that all Democrats would equal the number of committees with all Democrats divided by total number of different committees. So that's going to be 55 combination 7 times 45 combination 0 over 100 combination 7. You would use your calculator, calculate this out. It becomes 0.012676992. Now, this may not make a whole lot of sense, but if you rounded it to 2 decimal places, changed it to a percent, there's a 1% chance. There's a 1% chance that the committee will be all Democrats if the 7 are chosen randomly. That's a very, very small, which is unlikely. Now, what is the probability the committee is composed of all Republicans? Same, 55 Democrats, 45 Republicans. So all Republicans implies no Democrats. So in this case, number of committees with all Republicans, Democrats, you'd have 55 combination 0, because I don't want any, and Republicans would be 45 combination 7. Again, total number of different committees is 100 combination 7. So the probability all Republicans would be the number of committees with all Republicans divided by total number of different committees. So that's 55 combination 0 times 45 combination 7 divided by 100 combination 7. Use your calculator and you get this answer, which is smaller than all Democrats. And why would that be the case? Because there are less Republicans. Now, question C. It came up B again, but it should be question C. What is the probability the committee is composed of 3 Democrats, 4 Republicans? So this time, number of committees with 3 Democrats and 4 Republicans is, so the Democrats would be 55 combination 3, because I want 3 Democrats, times 45 combination 4, because I want 4 Republicans. Total number of different committees is still 100 combination 7. So the probability 3 Democrats and 4 Republicans would be number of committees with 3 Democrats and 4 Republicans divided by total number of different committees. So this would be 55 combination 3 times 45 combination 4 divided by 100 combination 7. Use your calculator. You would get 0.244189847. So if you rounded this off to 2 decimal places, change it to percent, there's a 24% chance that you'll get a committee with 3 Democrats and 4 Republicans on it. All right, now we want to talk about permutations with non-distinct items. The number of permutations with n objects, of which n1 are of one kind, n2 are of a second kind, nk are of the kth kind, is given by n factorial over n1 factorial times n2 factorial all the way down to nk factorial, where n equals n1 plus n2 plus all the way down to nk. Now, how many different vertical arrangements are there of 10 flags if 5 are white, 3 are blue, and 2 are red? Well, in this case, there's a total of 10 flags. So this is going to be 10 factorial, 5 are white, so that's 5 factorial, 3 are blue, 3 factorial, 2 are red, 2 factorial. So this becomes 10 times 9 times 8 times 7 times 6 times 5 factorial over 5 factorial times 3 times 2 times 1 times 2 times 1. We can cancel out the 5 factorials, cancel out the 3, 2, 6, 2, 8, and get 4. Now we can multiply this out, and we would end up with 2,520. Example 2. How many different arrangements are possible for the letters in the word statistics? Now, this one's going to be a little different than the author's definition. So n is 10. There are 3 s's, 3 t's, 3 i's. So we're going to let n1 be 3, n2 be 3, n3 be 2. All the other ones occurred one time, so I'm not even going to consider them. I'm only going to consider the repeated ones. So this is going to be 10 factorial over 3 factorial times 3 factorial times 2 factorial, because everything else would be 1 factorial, which is 1. So if I multiply this out, I get 50,400 different possible arrangements. Now, example 3. How many different arrangements are possible for the letters in the word today? If you look at the word today carefully, 5 letters, no letters repeat. So this is just going to be 5 factorial because nothing repeated, which is 120. Example 4. How many different arrangements are possible for the letters in the word tomorrow? Well, if you look at the word tomorrow, there are 8 letters. The O repeats 3 times. The R repeats 2 times. So this will be 8 factorial over 3 factorial times 2 factorial. Calculate this out with your calculator. You should get 3,360. And this brings us to the end of section 5.5.